So, we want to talk about causation, but before we talk about causation, let's talk about correlation. Uh, in general, in the world, things move. Sometimes they move together. And if we want to know if this movement of between two variables is causal, we must first be clear about what exactly this movement is where they move together. And that's what is called correlation. Correlation is when two things move together, even if there is no cause and effect. In general, correlation is the sum function. Rho is usually the notation they use. And it doesn't matter how the arguments in this function go, if it's a or b or ba. But more big picture, correlation between a and b is some, or between variables, is some space. And within this space, there is a subset which is causation. What does this tell us? It tells us that all causation has correlation, but not all correlation has causation. Let's have an example of a correlation that is not causation. Let's imagine one variable is people going to the cinema. Another variable is number of bats flying around. Clearly, these two will be correlated because they both happen at night. Bats fly around at night, and people go to the cinema at night. But it's not causal because, well, one doesn't cause the other. Bats don't cause people to go to the cinema at night, and people going to the cinema is not the cause of bats coming out at night. If we want an example of a correlation that is causation, we can use me grabbing this object. So one variable is my hand, the coordinates of my hand. The other variable is the coordinates of this object. And clearly, these two variables are correlated. When my hand is gripping this thing, and they're moving together, it might seem statistically, it is indistinguishable from me pulling the object versus the hand pushing, versus the object pushing my hand. So we must have some sort of framework to interpret what is the cause and what is not the cause. And in general, this framework is represented like this. We have one variable, A, which causes B. And then we're going to represent this by an arrow. Equivalently, we can represent B causing A, like this. And it's important to note that correlation can only catch a non-directed relationship between A and B. In other words, these two things are statistically indistinguishable from the point of view of correlation. So if we want to talk about cause and effect, we must come in with a theory before we even start doing data analysis.